This is finding limits graphically and numerically. To kind of understand the concept of limits, my wife used to have this dog, little carrion terrier, rat terrier, the total dog, and dumb dog, dumb as you could imagine. We have a German Shepherd. She's smart as could be. When she barks, there's somebody outside the house going around, and I'll go outside and see what's going on. The little toter dog, he'd bark constantly. A cloud would go across the sky, he'd start barking. Somebody shut the door in their car half a block away, he'd start barking. Scared of everything. Storms would come, he would start shaking. Just not very sharp. Well, I had both of them out in the yard one time, and I was getting ready to barbecue. Took my grill off, leaned it against a tree, started cleaning out the charcoal. And I look over there, and he's got his leg raised, and he's wetting down my grill for me. And I see red. I grab the hard plastic chair I have him sitting next to me, and I throw it at him with the intentions of killing him. Well, the minute that left my hand, nothing good was going to happen. I was either going to kill the dog, then I would have had to bury it somewhere and pretend I didn't know where the dog went to. My wife loved that dog more than me. Or miss the dog and break the chair. Well, my aim was poor, and I missed the dog and broke the chair. And the idea of limits is we don't care what's happening at that point. Like the minute that chair left my hand, it was too late. Something bad was going to happen. But we want to study it as we're getting closer and closer. If I could have studied my anger, in my head before I threw the chair, I would just set the chair down. Pee washes off the grill. Maybe makes hamburgers taste extra special that night. If somebody's going with some heart problems into the hospital, and here's their heart going, and here's a heart attack, and then trails off over in that end. Now, right here, it's not that important for the hospital to be monitoring this right here. As I understand it, heart attacks aren't like 1 hour events. They're very quick. Stroke is relatively quick also. Leading up to it, you may experience a lot of different symptoms. And then going on this side also. Well, it's important not to study it at that point because it's such a short event anyway, same with a stroke, but studying it going up to it. Because I've been told that if your heart is starting to approach a heart attack, whatever that means, they can give you nitroglycerin to help prevent it. Trailing off on this end, if your heart's starting to go like this, they can give you something to maybe stimulate it to get the heart going a little bit stronger. So it's important to study it on both sides. Not so much while it's happening, because that is not a real long event, but leading up to it. That's the idea of limits. We don't care what's happening at that point. We're studying it as it approaches from the left and from the right. Now I'm going to have a note here I'll put up before we look at our first problem. And it says, for a limit to exist, it has to agree approaching from the left and approaching from the right. And we'll see this with an example. Let's take a look at our first problem here. We got limit x, then an arrow 2, and then x squared minus 3x minus 2. Now what this is saying is we want to find the limit as x approaches 2. So that's what that arrow means, approaches. And of x squared minus 3x minus 2. This is a table method. And we got 1.9, 1.99 and 1.39s. And here we're wondering what's for 2. Now we don't care what's happening at 2. We're setting it as it gets closer and closer from both sides. So over on this side, we're going to have 2.001, 2.01, and 2.1. Now notice how this table's built. Here's 2. Here I'm adding 0.001 to 2. Here I'm adding 0.01 to 2. And here I'm adding 0.1 to 2. Now over here I'm subtracting 0.001. Here I'm subtracting 0.01. And here I'm subtracting 0.1. Now there'll be some problems in this section where you have to come up with your own table. And I would start off with these. Try adding 0.001, 0.01, and 0.1, and subtracting 0.001, 0.01, and 0.1. Now you may have to go more than that. You may have to have another column in here of 0.0001 through 3 zeros, and same on this side. You don't know until you get into the problem. Each problem's kind of different in that regard.
Avast virus database has been updated.
I hate how Avast does that. Okay, let's look at our first one here, 1.9. We're going to take 1.9 and we're going to plug it into x squared minus 3x minus 2. Okay, so we got 1.9 squared minus 3 times 1.9 minus 2. So we got, let's see, 1.9 squared minus 3 times 1.9 minus 2. And enter. Then we get negative 4.09. Now notice this is our y value. So what we're finding here at the limit is we're finding out what the y value is. So that's f of x. Double check myself here. There we go. Okay, now this would be, and we can go through and do the other same way. We plug in 1.99, 1.999, and so forth. There's an easier way if you got a TA3, TA4 calculator. If you don't have one, then I'll just plug it in and see what happens. We're going to go to a calculator, and we'll press y equals clear to clear out wherever's in that line. And I'm going to down arrow to y2 because I have a 0 there, and I'll press clear. Okay, so we don't want anything there. Now put in x squared minus 3x minus 2. Now above the window it says table set. So if I do second window, this is going to my table settings. And you see where it says independent? You want a down arrow to independent and right arrow and put your flashing cursor on the ask and press enter one time. Now that'll highlight ask, and that's what you want. Mine was already set that way. Now to exit out of your anything in your calculator, you just do second mode. Okay, now we're going to go into table mode, and you see above the graph button is table, so we're going to do second graph. And you probably don't have any numbers here. I do. I'm going to go ahead and press delete to clear those out. And what we're wanting to put here is our x value, so we'll put in 1.9. And then we get negative 4.09. What this allows you to do is to evaluate a function real quick. I'll put in 1.99. So 1.99. And we get negative 4.01. I'm going to put in the next one. 1.999. And that gives us negative 4.001. Now over on this other side, I'll put in 2.1 first, the one furthest away, just so we see it. So 2.1, enter, and that gives us negative 3.89. Let's put in 2.01. Enter. Then we get negative 3.99. and then 2.001. And we get negative 3 point, and then 3 nines. Okay. Now coming from the left side and from the right side, you can see they're both approaching negative 4. So negative 4 is our answer. Now again, we could care less what it's equal to at that point. We're just studying it. Was it approaching from the left and from the right? And they have to agree. They both have to be approaching negative 4 for it to equal negative 4. Let's take a look at our next problem. We got limit as x approaches 5 of x squared minus 25 over x minus 5. Actually, I guess that's f of x, isn't it? Not that matters. Y is fine, but to get it to match what I have on the page there. Got 4.9, 4.99, 4.3 nines, and 5, and this is what we're studying. On this side, I'm going to add 0.001, I'll add 0.01, and I'll add 0.1. Now the key to plugging this one in your graphing calculator is put parentheses around the top, parentheses around the bottom. Anytime you have more than a single variable on the top, more than a single variable or single number on the top or bottom of your fraction, you have to put parentheses around it. Okay, so we're going to press y equals, press clear. Actually, let me clear that out. So y equals clear. I do a beginning parentheses, x squared minus 25. So x squared minus 25, closing parentheses, divided by beginning parentheses, x minus 5. Closing parentheses. Now I'm going to my table mode. You don't have to do the table setting. It stays that way from here on out. So I'll do second graph. Now you have your old old values from the previous problem. If you want to clean those out, you just keep pressing delete over and over, and it'll delete them. Now as you type in new numbers, it overwrite what's there. But okay, so we got 4.9. We got 4.99 and 4.1239. Okay, so this is 9.9, 9.99, 9.39. Like that. Now coming from the other side, I'll start with the 5.1. 5.1, 5.01, and 5.001. Okay, so here we got 10.1, 10.01, and 10.001. So we're studying the limit as x approaches 5 and wondering what the y value is approaching. So here the x values are getting closer and closer to 5, coming from the left side and from the right side. And I see my f of x, my y values, is getting closer and closer to 10. So 10's our answer. Now notice our graph doesn't actually exist at 5. If I were to plug 5 in, 5 minus 5 in the denominator gives us 0. So it doesn't actually exist at 5. That doesn't matter. Because again, we could care less what's happening at that value. We're studying it as it gets closer and closer. Let's take a look at number 3. We got the limit as x approaches 0 of tangent x over x. And let's build our table. It tells us to create a table of values for the function, use the result to estimate the limit, use a graphing utility to graph function, confirm your result. You can look at the graph if you want. We're just going to build a table. Okay, so 1, 2, 3. Here's 0. 1, 2, 3. Now, just like before, I'm going to come over here and I'm going to add 0.001. Here I'll add 0.01, and here I'll add 0.1. Here I'll subtract 0.001. Here I'll subtract 0.01, and here I'll subtract 0.1. So this value here, 0 plus 0.001 is 0.001. 0 plus 0.01 is 0.01, and 0 plus 0.1 is 0.1. 0 minus 0.001 is negative 0.001. This is negative 0.01, and this is negative 0.1. Well, we have to plug this into our calculator. We have to make sure we're in radians. So I'm going to come over here. I'm going to press my mode button, and I'll down arrow to this line where it says radians degrees. You want to make sure radians is already is highlighted. Now mine's already highlighted, so I'm fine. But if yours isn't, put your flashing cursor on radian and press enter one time. Then second mode to exit out. Okay, now we're going to go into our table, so we do second graph. Got my old values, so I'll up arrow and keep pressing delete over and over to clean those out. Okay, and we got negative 0.1, negative 0.01, negative 0.001, and that appears to be approaching 5. We got 4.9, 4.99, and 4.39s. But let's see from the other side. I'm going to start with the 0.1. So 0.1, enter, 0.01, enter, 0.001, enter. And here we have 5.1, 5.01, 5.001. So coming from the left side and from the right side, the f of x appears to be approaching 5. Did I didn't type that in. Okay. Slipping. Let me come here and put tangent x. I was going to say those values seem kind of weird for tangent. Divide by x. There we go. Okay, let me try it again. Now if I go to my table, got to erase these now. Sorry about that. Sun was in my eyes. Wife was screaming. Wait a minute. There's no sun in here. Wife's gone. Pick up my son, so that can't be it. I'll just go and see now. It says 1.0033. 1, 1, and over on this side, we got 1.0033 and 1 and 1. So it appears to be approaching 1. And it goes to it pretty fast, actually. See how this went from 1.0033 to 1, and then 1, and then same thing here. So how many do you need to add 0.001? Can you get by with 0.01? I don't know. Each problem's different. You have to kind of look at that and go from there. Okay. Let's take a look at this one. Got limit as x approaches 2 of x squared minus 5x plus 6 over x minus 2. Now I'm going to go ahead and type this in before I forget it again. So again, the key is if you have more than a single variable up on top or single number, you have to put parentheses on it. Same down below. So that's how we're going to enter it in. Okay, so I press my y equals, press clear. I'll do a beginning parentheses, x squared minus 5x plus 6. Closing parentheses divided by beginning parentheses x minus 2. Closing parentheses. Okay, now let's look at how our table should go. We got x, f of x. And just kind of use the same setup as before. This is 2. And here I'm going to be adding 0.001. Here I'll be adding 0.01, and here I'll be adding 0.1. Here I'll be subtracting 0.001, subtracting 0.01, and subtracting 0.1. So we're going to have 2.001. We'll have 2.01, 2.1. Over here we'll have 1.999, 1.99, and 1.9. Well, let's plug these in and see what we get. So I'll go to my table mode. I'll do second graph. I'll press delete over and over to clean out those numbers there. Okay, so we got 1.9 inner, 1.99 inner, 1.999 inner. Appears to be going to -1, but let's see. We got negative 1.1, negative 1.01, negative 1.001. Now coming from the other side, got 2.1, 2.01, 2.001. Okay, so we got negative 0.9, negative 0.99, negative 0.39. Okay, so as our x values are approaching 2, our y values appear to be approaching -1. So -1's our answer. Grab a drink here. So let's go ahead and save this page. What in the world is finding limits graphically and numerically? Okay. So limits numerically and graphically. Page 01.pdf. Okay. Start a new page. There we go. Now this one shows how to find a limit graphically. Okay, so here's 1, 2, and I need 2, 8. 5, 6, 7, 8. So 2, 8 would be right here. And I know that isn't perfect, but it doesn't need to be perfect for what I'm showing you. In part A, it says we're finding the limit as x approaches 1 of our function. That's our graph. Okay, now we're basically tracing our graph. So here we're saying x is going. We're getting closer and closer to 1. So x is approaching 1. Well, here's x equals 1. So here's my graph, and I'm getting closer and closer to x equals 1. That's from the left side. Now coming from the right side, I'm getting closer and closer to x equals 1, tracing my graph. Again, this is x equals 1. Then you ask yourself, well, what is the y value approaching? Well, if I go straight over to the left, this is y is equal to 2. So that'd be your answer. And the other one is limit as x approaches 2 of f of x. Well, here I'm tracing my graph again. I'm getting closer and closer to x equals 2 from the left side and then from the right side. And the question is, what is the y value becoming? What is it approaching? Well, if I go straight over to here, that's y is equal to 8. So it's approaching 8. And those would be your answers. Okay. We got 1, 1. And then we got 1, 2. Like that. And the first thing we're going to find is limit as x approaches c, which what looks like the plus power of f of x, and specifically here they're telling us c is equal to 1 in the instructions. Well, we can plug 1 in for the c. So this is equal to the limit as x approaches 1 to the plus power f of x. Now that's not really the plus power. What this is, this plus here means we're studying the graph as it comes from the right hand side. So we're studying the graph coming from the right hand side. Now I'm getting closer and closer to x equals 1, which is, here's 1, coming from the right hand side. Okay, so I'm getting closer and closer. X equals 1 coming from the right hand side. Look what our y value is. It's 2. So that's equal to 2. Now b says the limit as x approaches c, what looks like negative power of f of x. And c is 1, so it'll be that way. Now, if the positives from the right-hand side, you can probably guess what this is. What looks like the negative power means you're studying it from the left-hand side. And that's the only place we're looking. Okay, well, coming from the left-hand side, here I am getting closer and closer to x equals 1. And look, if we go over, that's our y value. So y is equal to 1. And then part C, limit as x approaches c of f of x. And c we said was 1. So we got limit as x approaches 1 of f of x. Now, remember what I said earlier. The limit has to agree coming from the left and from the right. Well, these don't agree, do they? 1's equal to 2 and 1's equal to 1. So this limit does not exist. And I'm just going to write D and E from here on out when we have a limit that does not exist. Let me save that. By the way, up here where we're setting limit as x approaches 1, and then we said it's equal to 2. The question is, how close does it have to get to x equals 1, your graph, in order to accurately say that your limit is 2? Well, that's what the next problems will address. Okay. So number 7, we got limit as x approaches 2, 5x minus 1. Okay. Now, we're going to see in the next lesson that we got a direct substitution way of finding a limit, where you put the 2 in for the x. So 5 times 2 is 10, minus 1 gives us 9. So this limit here is actually equal to 9. Well, the question becomes, to prove this, well, this is, we'll label this as L. What's inside the parentheses here is f of x. And the 2 is our c. And what they're saying is find the limit L, then find delta greater than 0, such that the absolute value of f of x minus L, so f of x minus L, is less than 0.01 when 0 is less than x minus c is less than delta. Okay, so let's plug in what we know. We said f of x is 5x minus 1. So I got 5x minus 1 minus L, which was 9, is less than 0.01. And over here, we got x minus c, and c was 2. So we got x minus 2 is less than delta. Now our goal first is to take this problem over here and get the left side looking like this. So we want it to look like absolute value of x minus 2. Well, let's simplify this. 5x, negative 1, negative 9 is negative 10. Now we can factor out of 5, and when we factor out of 5, we can actually factor it completely out of the absolute value. Reason why, it's a positive 5, so it can freely go in and out of an absolute value. Now I want to get it to look like exactly like this, so I'm going to divide both sides by 5. So I divide both sides by 5. And we get the absolute value of x minus 2 is less than 0.01 over 5. Okay, now the absolute value of x minus 2's cancel. Can't cancel. They match. Since those match, this right here matches that right there, then we can equate the right sides. So that would tell us that delta is equal to 0.01 over 5. Well, what does this say? Well, in order to now we got our f of x, and we got our actual limit. When you're going to get this less than 0.01 is when the difference between the x value and the 2 is less than delta, which is this value. So that's, how close do you have to get? Remember me talking about, do we add 0.001, do we add 0.01, and so forth? Well, this is a guideline to help you figure out if you actually found your limit. Now, we know we found it because this was a direct substitution one. Now, for purposes of my class, I'm happy to get down to here. These don't play a huge part in working problems throughout Calc 1. It's important to understand it from the theory side. Okay, so we got delta. Well, let's go backwards. Let's start with this one here. So we'll start with the x minus c is less than delta. Well, c we said was 2. So that's x minus 2 is less than 0.01 over 5. And now what we want it to do is we want it to look like the left side. So we're going to try to work backwards there. Well, here I'll multiply both sides by 5. So I got 5 times my absolute value of x minus 2 is less than 5 times 0.01 over 5. I can take the 5 inside the absolute value. So we've got 5, and I'll go ahead and multiply it through. 5 times x is 5x. 5 times negative 2 is negative 10. Now those 5's cancel, and we've got 0.01. Well, that's closer. And you're just kind of going in reverse. Here we're at this step, so we're going here, and then we're going here. So I'm going to split up the 5x minus 10 into 5x minus 1 minus 9 is less than 0.01. Why did I do that, besides the fact that it was in this step? We want this to look like our f of x. Remember f of x. F of x was 5x minus 1. So that's why we want a 5x minus 1 here. Well, then the f of x will replace the 5x minus 1 minus 9 was our L is less than 0.01. So that's our proof on that that particular limit. Let me save that. Well, 3. And let me grab a drink here. Now I put those into steps. Okay, this says find the limit L. Well, you might be able to find the limit L by doing the graphical method. Then we're going to find delta, which is greater than 0, such that f of x, absolute value of f of x minus L is less than 0.01. Whenever 0 is less than absolute value of x minus c is less than delta. We identify c, f of x, and L. We'll plug in c into absolute value of x minus c and plug in f of x and L into this formula. And then get the absolute value by itself such that it looks like the absolute value of x minus c. Then the other side is delta. And on some problems, instead of it hard-coding 0.01, you replace it by epsilon. Looks like a little an e. That epsilon represents a very small number. Let's do this one using epsilon. This is the epsilon-delta definition to prove that the limit is L. Okay, let me straighten out my little sheet here. There we go. Then we got limit as x goes to 4 of 2x plus 1. And of course we need the limit on this, so I could look at the graph to see it, or we'll see in the next section is a direct substitution. So we plug 4 in for the x. 2 times 4 is 8, plus 1 is 9. Now this is going to be L. This is f of x, and this is c. So we're going to have absolute value of f of x minus L is less than epsilon when 0 is less than the absolute value of x minus c is less than delta. Well, let's plug in what we're given. F of x is 2x plus 1 minus L, which was 9, is less than epsilon. When plug in 4 for the c here, so we got x minus 4 is less than delta. Now what we want to do is we want to get this absolute value looking like this. Well, let's combine together the numbers. So we got 2x, 1 minus 9 is negative 8. It's less than epsilon. Factor out of 2, and that leaves us the absolute value of x minus 4, which is looking close. Now we just need to divide both sides by 2. And we got the absolute value of x minus 4 is less than epsilon over 2. Now I got the this to match that, which means that the right sides will match. So that says that delta is equal to epsilon over 2. Now we want to go backwards now. So we're going to start with this formula here. So we got absolute value of x minus c is less than delta. Now c we said was what did we say c was? 4. It's less than delta, which is epsilon over 2. Well, again, we're trying to get it to look like this, so I'll multiply both sides by 2. Those 2's will cancel. Multiply that 2 through, and we got 2x minus 8 is less than 2's cancel there, and we got epsilon. Now, ignoring the steps we have there, we want our f of x in there. F of x is 2x plus 1, which means I need to split this up. This will become 2x plus 1. Minus, and we want it to equal this, so I think what value can I put here that would give me this? Well, if I put a 9 in there. 1 minus 9 is negative 8. It's less than epsilon. Now remember, at 2x plus 1 is f of x, minus, and 9 was L. And then that's less than epsilon. And that's the end of that problem. So let me save that. believe that's time for the tablet to blow up. I think that's the last of the slide. Yep, so let me stop my recorders.